In this video, we are going to move on to day 5. And in day 5, we are going to take a break from the exponential rules and move on to graphing an exponential function. So what I want to begin with is comparing a linear equation to an exponential equation. So if we start with linear, of course, here is our y equals mx plus b. So that's our linear equation. It'll make a straight line. So just to kind of review again, your m here, that is going to be your slope. We also refer to that as your rate of change. Okay, it gives the angle to the line on the graph. Okay, that's your rise over run. And then the b value, notice it's the value without a variable attached to it. That is your y-intercept. As far as when we graph, that's going to be our starting point. So we graph the b first, and then of course we do the rise over run off of that. Now, comparing that to an exponential equation, it says a times b to the x. Okay, so it might look like this. A and b are numbers, so it might be something like 4 and then parentheses 2 raised up to the x power. Okay, so we'll always have the x and the y in it, but the a and the b are going to be numbers. So the a value is actually the starting value. So it's kind of like the y-intercept in a way. It's kind of where it starts. And then the b value is going to be our growth or decay. Oops. Growth or decay. So, of course, linear equations, of course, make just a steady line. Okay, so if we had a linear equation, it would be some sort of line. It could be that direction, it could be negative. Many times our exponentials start out really flat and then jump really fast. Okay, or it could decrease really fast and level off. I mean, the most obvious example right now is the statistics with the coronavirus. It started out really flat and then it has just exponentially grown and jumped. So a couple other things. Let me do a couple of examples down here. So linear equation, let's just consider y equals 3x plus 2. Okay, so when we look for, if we want to describe a linear with a pattern, so we talked a little bit about a second ago that your slope is 3, okay, that's your rise over run. And so really what's happening is we're just increasing this every single time by the same number. Okay, so I'm going to put a little note here that says adding the same number. Adding the same, I'll just use the number sign, adding the same number. So it's going up 3, and then another 3, and then another 3, and then another 3, that type of idea. So here would be another example of an exponential equation. Y equals 2, and then we would put in parentheses the next number, 3, to the x power. So it's not adding the same number, it's multiplying the same number every time. That's why it's growing so fast. Okay, so it's going to be multiplying that same number every single time. All right, we're going to come back to that some more with patterns. So let's work on actually putting these on a graph. Okay, so I said a second ago, we're going to have some sort of picture like this. It's going to either start really flat and grow really fast, or it's going to start really high and then drop really fast. All right, complete the table and graph the following functions. So what I want you to see here, it is in the form of an exponential equation because it is to the power of x. That's the big distinction here. Let me back up. Linear has a slope 3 times x. Exponential will be raised to the power of x. That's the big distinguishing factor here. When we graph these, we are simply going to plug numbers in and make a table of values. Okay, so we're going to take -2 and plug it in. So we would have, I'm going to over here right to the side. So we would have y equals 3 raised up to the -2. Now we can apply our exponent rules here. If we did the reciprocal, that would be 1 over 3 squared, and 1 over 3 squared is 1/9. Okay, maybe I'll switch over to this side. Plug in -1 for x. So y equals 3 to the negative first power. Well, do the exponent rules for a negative power, flip it over, so it would be 1 over 3, which is 1/3. Okay, continue to plug in. Y equals 3 to the 0 power. Well, anything to the 0 power is 1. Now plug in 1. Y equals 3 to the first power. That would just be a 3. And then lastly, y equals 3 to the second power, which is 9. Now, when I go to graph these, I would probably turn 1/9 into a decimal. So 1/9 is about 0.111 and on and on and on. And then 1/3 is 0.333 on and on and on. So the main thing I want you to take away from that is that 0.11 is smaller than 0.3. So that means when I go to graph it, this ordered pair of 2.1, the 0.1 is going to be just a little lower on the y-axis. And it's going to be so close, it's going to be hard to tell. But remember, I'm trying to make this kind of picture right here. All right, so it doesn't have to be perfect. It just has to be in the right spot, I guess. Okay, -2, 0.1. So -2, and then I'm just going to barely go above 0 on the y-axis. And then -1.3 is just a little bit higher. So it's really, really small difference. 0, 1, 1, 1, 2, 3, and then 2, 9, all the way up here. So when I go to graph it, on the left, my line is going to just hover above the y-axis. So go through your dots, and then it's going to jump really fast. And so we need arrowheads on the end of it because it's going to go on forever. So this left-hand side right here, it's not going to dip down ever. It's going to just hover right across along the y. Because if you plugged in, let's say we plugged in a -10 for the x value here. Let's go back up to the equation. If I do 3 in my calculator and raise it to the -10th, I get 0.000016. So it's barely above 0. So that's why we're just going to hover. And that's it. That's how we're going to graph these functions. Now, one thing I want you to see here. So this is going up. I mentioned at the top here, growth or decay. So this is considered a growth function. It's growing really fast here as it rises. We're going to talk more about that in another section, but I just want you to recognize if it's going up like that really fast, it is growth. Okay, let's do the second one. So substitute in. Now, you can use your calculator if you want to. I'm going to just reinforce those exponent rules. So let's plug in -2 for x. So I'm going to be doing 1/3 raised to the -2. So I can, since I have a fraction to a negative power, I can just flip the fraction and it will turn the power positive. So that's really 3, not 3 over 1 is really 3. 3 squared is 9. Okay, -1. So 1/3 to the -1 power. So flip it over to the first. So that's just really a 3. 1/3 to the 0. Anything to the 0, just 1. 1/3 to the first, of course, is just a third. So you can kind of see the pattern. 1/3 to the second would be 1/9. So it's kind of the opposite of what we just graphed. So I might, since I did this a second ago, let's pick up those decimals, 0.1 and 0.3. So remember, I'm just going to call this 0.3 and 0.1 when I graph. Okay, -2, 9. So to the left 2 up to 9. -1, 3. -1, 1, 2, 3. 0, 1. So then remember, 0.3 is just a little bit higher than 0.1, just a little bit bigger. So +1.3, I'll kind of be right here. And then the next one, I'm just going to try to make it a little bit lower. Okay? But I get the general idea of my curve. So it's going to start up at the top here, drop down, curve through. And then remember, you're just going to hover above your x-axis and put arrows on the end because it does continue on. So again, it's going to go forever to the right. So like if you plug a 10 in, let's say if x were 10, I should get something barely above 0. So if I do 1/3 and I raise it up to the 10th power, I get that point 0.0000169 like I checked earlier. So this is dropping really fast. This is a decay function. Okay. Okay. Well, I want you to pause the video and turn the page and do number 3. You're going to graph that function. Actually, I might get you started on this and then I'll have you pause it. So don't pause just yet. All right, when you plug this in, and again, you can use your calculator if you want, or you can do the exponent rules. So here's what we're going to do on this when you plug in -2. You're going to be doing 3 times 2 in the function, but you're raising it to the -2nd. So I would recommend going ahead and typing this in. 3 times 2 raised up to the -2nd. And so we get 0.75 or 3/4 if you leave it as a fraction. Okay, so that's how you're going to raise the number in parentheses first to the negative power or to the power and then multiply by 3. Okay, pause the video and then come back and let's compare the graph that we got. Okay, I want you to notice here I got 0.3 because when we do 2 to the 0, we get 1, and then we multiply by that 3. Okay, let's see what our picture looks like. Okay, -2.75 is, I'm going to put it about right here. Actually, maybe a little higher. So it's almost 1. -2, so maybe like about right there. -1, 1.5, so approximately there. 1, 2, 3. Okay, I'm going to go off the graph here, but this is 10, 11, I don't know, approximately right here. But I'm going to have that same curving happening. So it's going to eventually flatten out and hover right above the x, and then it's going to curve up. And then go like that. So again, here's another growth function. Okay, so that is our graphing an exponential function. So we're just going to make a table of values. Okay, last couple here. We are trying to match some information. So number 4 says, which equation matches the data in the table? Okay, now, what I would recommend here, so we've got x's and y's. We could just plug in the x value into the choices here. So what I mean, like number 1, we could plug in a 1 right here. And do we get what's in the table? So if I do 2 to the first, I get +2, not negative. So it can't be A. So do the same thing for B. Plug in let's stick with 1. Let's plug in 1 right here. So you're doing 2 times 1, which is 2. And the table says it's -2. That's eliminated as well. All right, plug a 1 in here. -2 to the first. Okay, that seems like it's going to work out, but let's try D. If we can eliminate D, then we don't have to move on and check any other numbers. Let's plug in 1. So if I do 1 squared, I get 1, which is not that -2. So C is my answer. If I would have gotten D or any of the others to match, then I have to check some of the other values in the table, but I didn't have to seem to move past 1 on that one. All right, I would like you to try number 5. please pause the video. Sorry about that announcement. Please pause the video and see, is it A, B, or C? Which one matches that equation? Okay, one thing you could do here, and I know it's a little bit hard to tell, do you see how the graph is crossing at 0, 1, 0, 1, so that's crossing at 0, 1, and do you see how this one is crossing at 0, negative 1? So let's start by plugging 0 in for x, and what do we get? So if I plug in negative, and then the parentheses 3 to the 0, I get negative 1. Well, that right there, so if I plug in 0, I got negative 1, that helps me to quickly eliminate A and B, and C is the correct answer. I also want you to notice the negative right here. So do you see how the negative is in front? That's making the graph open, like flip over and go down. So we're going to talk more about those properties later, but what I want you to take away from this lesson is the graphing component and starting to get used to what this exponential, equation